Hello everyone, good afternoon. Dear authors and invited guests, we are welcome to the technical session 9E. Myself Prashi and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastics LLP, it is my great pleasure to welcome you to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The ninth edition of this conference is being organized in a hybrid mode. The physical event was held the day before yesterday in Pune, India, and the virtual event is being held through Zoom yesterday and today. It is 30th and the 31st of January 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presenters. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. Please note that on 7th minute, I will raise a gentle reminder. There is another request to all the participants that you will all have to stay connected with us till the closing remarks. If you have any queries or update, then you can write it to me in the chat box. Just before we start with the session, I would like you to know about our session chair. Our session chair would be Dr. Vandana Rani Verma, Associate Professor in the CSC Department at Galapagos College of Engineering and Technology, Greater Noida, India, with 9 years of teaching and 8 years of experience in research. She has published 21 international research papers and presented at several national and international conferences. Dr. Verma has also served as a convener for international conferences and has also been a session chair for several academic events. Now I will start ahead with the papers. I would like to call upon our first presenter. Our first presenter is A. Kausar Nikhat, presenting paper on the titled A Multilingual Deep Learning Approach for Sign Language Recognition. If you are available with us, I request you to kindly take over with your presentation, please. A. Kausar Nikhat, if you are available, I request you to kindly take over with your presentation, please.
Yeah, I am available.
Okay, ma'am. Good morning. You can take over the presentation, ma'am. I'll stop sharing my screen.
Yeah, 1 minute. Just give me 2 minutes of time. Yeah.
Okay.
And what is the paper ID? I have two IDs. Now one is 738 and one is 741.
Ma'am, the paper title is A Multilingual Deep Learning Approach for Sign Language and Recognition.
Okay, yeah, we'll. Good morning, all. This is Kausar Nikhat. So I am just sharing this project one called as multi-language deep learning approach for sign language recognition, and our ID is 738. And myself, along with my teammates, our work on language recovery.
There is some glitch in the network. We are unable to hear your voice or see the presentation now. If you want time to rectify this, you can take the time, ma'am. We can go on to the next presenter for meanwhile. You are not audible, ma'am. Okay, looks like we have some technical glitch. So we'll move on to the next presenter for the presentation. Our next presenter is Ritesh Kumar Shanti, presenting the paper on the title A Review on Imagify and Image NFT Marketplace. If you are available with us, I request you to kindly take over with your presentation, please. Okay, sir. Uh,
Yes.
could you please take over with your presentation? Should I
Good
stop sharing? Okay.
Hello,
afternoon.
can I give now? I think I was just having a net issue.
Just a second, ma'am. 1 second.
Okay.
I request, ma'am, we'll take sir first. If possible, then we'll come to your presentation. So you
Okay.
can start sharing.
Okay.
Mr.
Whom should we?
Ritesh Kumar Shanti, sir, could you start sharing your presentation, please? Looks like there's some glitch. Ma'am, uh, Miss Kausar Nikhat, ma'am, I request you to kindly take over with your presentation.
Yeah, yeah.
Oh,
Okay. Okay.
thank you so
Okay.
much.
Where is it sharing? No, but PPT. Hello, is it now visible, ma'am?
Yes, ma'am, your your screen is visible, ma'am.
Okay, okay. So we have the architecture where followed by user and the model and then the output. Next where we have samples of things. And the next technical specifications part will be explained by my student. So these are the results. I'm just planning. Next, next. These are the results. This is the input. How this is how we give, and then we generate the text output in a native language. So here we have the textual content as Kalashala. Okay. Hello.
Yes, ma'am.
Yeah. That's it, ma'am. This is how our work was done, and we have done this work in our lab, followed by our student team, and which was a part of the major project activity. And we also have tried this model with various students in our lab, and we have got good result. So we are planning it now to even to connect with some NGO so that can be giving a good result for the sign analysis. Thank you. Thank you for giving this opportunity.
Thank you so much for your presentation, ma'am. Now we'll call upon the next presenter. Our next presenter, I request you to kindly take over the session with your presentation. It is Itesh Kumar Shanti presenting on the paper titled A Review on Imagifying and Image NFT Marketplace. If you are available with us, I request you to kindly take over with the presentation, please.
Yes, I'm available now.
Okay, sir. I just stopped sharing. I request you to kindly take over. So, are you presenting right now?
Yes, I'm presenting.
Okay. Yes, now it is visible.
Is it okay?
So we can see the SMARTCOM team now. Yes, now we can see your presentation, sir.
Yeah. Yeah. So, are you able to see the screen?
Yes, sir, we can see the screen.
Yeah. So, good afternoon, everyone. I'm here. I'm Ritesh Kumar Shanti. I'm here to present a new project idea which is Imagify. So let's talk about the problem statement first of all. So what we are solving is that we are integrating image modification, let's call it as image transformation, along with a dynamic NFT marketplace. So why is there a need to integrate Imagify, like image transformation, with NFT marketplace? Because let's say if you want to sell your digital images, like digital collectibles, any kind of digital collectibles, be it art or anything. So if you want to sell them, first those images, to restore those images, and then mint those as NFTs, and then sell throughout the global market. So in existing applications, there are many NFT marketplaces in the market. But what's different in our application is that we are not just providing the dynamic NFT marketplace, we are just integrating image transformation with NFT marketplace. So it's not a normal NFT marketplace, just we can buy, sell, and all, do all those stuffs. Okay, so what are NFTs? NFTs are one of a kind, like they are digital tokens, okay, which helps to show ownership of any unique item. In this case, in our project, we are converting art, digital art, into NFTs. Okay, and these NFTs can be owned by anyone throughout the world, and these ownership and authenticity is governed by smart contracts. And the users are, they are helpful to industries such as gaming and any industry which requires, digital ownership. Yeah, so benefits of NFTs, if I speak about, it provides authenticity and ownership, as I've informed. Sorry for the interruption. Yeah, and it also provides royalties for content creators. What kind of royalties? It provides financial aid to the content creators who are uploading their digital collectibles for sale in the global market, and it provides them sort of global reach, and it also increases market efficiency. Okay, as there are many options for the users to own the digital rights of any kind of image or any kind of, photo, any sort of that. So the existing systems, existing methods, you call, there are many fragmented platforms, like we can say OpenSea. OpenSea is also a platform which is an NFT marketplace platform basically. But the only thing is that they provide NFT marketplace, just it's a static NFT marketplace. It doesn't integrate any kind of software as a service or any kind of thing. You can just buy, sell, and just leave it. But what are the limitations of these systems? Of course, the transaction costs are very high, and there are many scalability concerns as well. The applications are very slow, and the transactions are not processed quickly. Okay, so what is our proposed system? We are using AI tools to modify the image and then mint them as NFTs and put it in sale. So we are not just selling those NFTs and leaving. We will help users to modify those images and then mint them as NFTs. So this keeps users engaged, and it also has decentralized payment system for software as a service that we are providing. We are providing image modification, We are providing NFT marketplace. So obviously this is a pay per use model. So the payments are decentralized to ensure security. So this is the use case diagram. User can leverage image transformation features like image restoration, recoloring, object removal, generative fill. These are image transformation features, and users pay for those features, and they can view the transformed images. And the NFT conversion related tasks, NFT conversion, ownership transfer, to sell and buy NFTs, these all tasks are managed by a smart contract, blockchain smart contract. So the buyer can buy the NFT if he or she wants to gain the ownership rights of that digital collectible. So this is the proposed implementation architecture. There's a front end and back end. Both are, both interact with each other using API calls. We integrate Cloudinary AI. It's a cloud tool. It's a cloud AI tool, cloud based AI tool, which we are integrating with, so that we can leverage those image transformation features. We are integrating MetaMask wallet also to manage transactions. And with the backend, we are integrating the smart contract as well as NFT metadata generation using LangChain LLM. What we do is that we'll
Sorry to interrupt you, sir, but we
convert
have
the images, and
sorry
then
to
we'll NFTs that we are going to create.
sorry to
Integrates.
interrupt you, sir. We have exceeded our 7-minute criteria.
Hello.
I request you to kindly conclude your presentation at the earliest, please.
Yeah, yeah, sure.
Okay, sir.
So these are the papers actually. I'll not go in deep. Okay. So to conclude, what are our two objectives? I just want to say these two objectives, and I want to conclude. Our objective is to uh, monetize the digital art and manage digital content ownership. So these are the two objectives of our project. Thank you. Thanks for giving
Thank you so much, sir.
the opportunity to present.
Thank you so much for your presentation, sir. Now we'll like to call upon the next presenter.
Thank you.
Thank you. Our next presenter is our VSS Surya Abhishek, presenting their paper on the titled AI and Computer Vision Techniques for Fitness Training and Form Analysis, a comprehensive review. If you are available with us, I request you to kindly take over your presentation, please.
Yes, Prachi, I'm here.
Okay,
Let me
sir.
just quickly set up. Can you see my screen?
It is visible to us right now. Yeah, now we can see your presentation.
All right. Thank you. Hello, everyone. So the paper that I'm putting forward is on AI and computer vision techniques for fitness training and form analysis, a comprehensive review. So essentially, what I'm putting forward is a review paper, which reviews all relevant articles to form analysis on the basis of computer vision techniques. So why do we even need to do this? Why do we even need a computer vision technique so that you can work out in your home? As we know, there are a lot of corporate jobs right now. That is the typical lifestyle that one is following right now, and there is a lot of sedentary aspects to a corporate lifestyle. And so going to the gym would be a hassle because you wouldn't be able to find time. You wouldn't be able to make time to go to the gym. So working out in the comfort of your own home is something that will for sure blow up in the near future. So to facilitate that, there should be a lot of computer vision research into the computer vision techniques to enable that. So my research is based around OpenPose, MediaPipe, and AlphaPose. These are technologies out there that essentially extract key points of body so that posture and form analysis can be done, using which users can work out in their own home and essentially also cater to the requirement of following proper form so that there is no injury, accidental injury that takes place. So, despite progress, challenges remain in real time accuracy, adaptability, and personalized feedback. I will get into this in a little while as to how, even though there's a lot of research on these topics right now, there is still a lot of improvement that can be done, and how that is. We'll get into that in later slides. But like I mentioned, the background is based around the fact that going to the gym is actually difficult to incorporate into your lifestyle right now. So working out in your home would be beneficial to everyone, and for that, to enable that, computer vision and AI is coming into picture. Now coming to how I did my research and what all papers I've taken and what is the shortlisting criteria that I've followed. The research is based around AI-driven posture estimation, like I mentioned, exercise tracking and real-time feedback. And also the databases searched include these, mainly focusing on IEEE Explore and Science Direct. Initial search comprised of around 100 plus records, and I've shortlisted that down to 30 studies. And then for detailed analysis, I've chosen 15 studies out of those. Coming to how I've included relevant articles. Again, like I mentioned, the research is based around these particular technologies, which are MediaPipe, OpenPose, and AlphaPose. And again, the feedback mechanism that is incorporated so that users can also acquire feedback and then correct their posture to ensure that there's no injury. And also based on abstract keywords and titles, relevant articles were shortlisted down from those 100 records, and then 50 studies which were actually implementing state-of-the-art technologies, and then I also had good feedback mechanisms in place. So yeah, like I mentioned, analysis was done on the basis of state-of-the-art technologies that they've incorporated. Now, let us quickly get into what these are. MediaPipe, OpenPose, and AlphaPose. MediaPipe is something that was put forward by Google developers. I apologize for the inconvenience in the background, but MediaPipe is essentially what was put forward by Google developers so that key points of the body can be extracted, based on which error in the angles can be calculated, and then feedback can be given to the user if the posture that and the form that they're incorporating in their exercise is in the right threshold or no. So according to that, users can again fix their exercise so they can perform the exercise in a healthy fashion. So that is MediaPipe. MediaPipe is the most popular framework out there. OpenPose or AlphaPose, again, they come after MediaPipe but also implement the same functionality. OpenPose in particular is more accurate than MediaPipe in general, but again, there is a trade-off when it comes to accuracy and the computational complexity. Because there is more accuracy in OpenPose and a little more in AlphaPose as well, they are more resource intensive in nature and require more resources and computation power. Uh, so yeah, going forward, I feel like in this domain, MediaPipe would stand out, and is already making its name pretty popular because of how efficient and lightweight it is. Now, moving forward, let us quickly discuss what each paper that I've covered entails. The first paper includes posture estimation done with MediaPipe and OpenCV, like I mentioned, but there is no feedback and personalization in this particular paper. Although almost all of the papers I've included does rep tracking, which is repetition tracking. So let's say you're doing squats or push-ups in your own home, and you're trying to you're trying to make sure that the application that you're using counts the number of repetitions that you're doing, but that is not uh, but that does not necessarily have feedback. uh, Most of the applications that I'm going to go through right now, most of the research that I've been through, it shows that there is no proper feedback in place. It's almost always about rep tracking. I understand that accuracy in rep tracking is important, but feedback is also important. Making sure that the user corrects their form is what we're trying to accomplish in the first place. So that is why, for future purposes, I propose a research on that. But for now, just to review all the papers that are already out there, no feedback and personalization, like I mentioned in this paper. In the second paper, on the addition of OpenPose, which is another alternative to MediaPipe, like I mentioned, There is also deep learning networks which are put in place, so that recognition accuracy is again enhanced with an accuracy of 95.6%, like I mentioned here. Coming to this particular paper, this deep 3D human pose estimation review, this served as a base paper for almost all the entire literature survey that I am going through, because this really delineates how deep learning models can be used for pose estimation. Like I mentioned, served as an important base paper for further research. Going forward, this also, like I mentioned, there's no feedback in this paper as well, but this uses an MLP to output the difference between users form and standard form. Again, this goes a step forward from the initial paper that I've discussed. Even though there's no feedback, but there is a network, which is a multi-layer perceptron network, which outputs the difference between user form and standard form. So there is a certain level of feedback that is incorporated, but not in its entirety.
Excuse me, sir. We have exceeded the 7-minute mark. I request you to kindly conclude your presentation at the earliest, please.
Yes, all right. I'm taking that into consideration. There's just a few more papers that I want to go through which are more relevant. Fifth one, like I mentioned, again uses media pipe, and there is no particular feedback in place in this as well. Coming to the next one, tackles only rep tracking and is limited to 2 exercises. Again, no feedback. In this one, system captures the pose of the user with a fixed camera transforming an image and provides guidance through video or voice. So this one does incorporate feedback. So you can see that there is progress in the research that is happening in this field. And coming forward to the eighth paper here, open pose again, just to compare the different technologies that are that can be used, I've chosen this paper open pose to compare how relevant or how more accurate it is when compared to media pipe. I've chosen the eighth paper. Ninth paper is specifically for yoga poses and not really for gym exercises like push-ups or pull-ups. But I thought it was relevant to my research because essentially media pipe is being used in the background, and again CNN to identify and classify the yoga poses. 10th one, again, alpha pose is used here as opposed to media pipe. This is the first paper that I'm covering that uses alpha pose instead of media pipe and open pose. And you can see this uses a multi-person tracking approach because alpha pose is known for that. 11th one includes machine learning as opposed to KNNs that we've seen. Again, this also incorporates feedback to some extent, but the point I'm trying to make here is there is no very accurate feedback mechanisms in place in research out there, and that is something that we all of us as a community should delve into, so that good advancements can be made in this field. And then the next paper also is based on yoga, uh, and 13th paper here uses a horizontal translational matrix for random video frame cutting. So again, this uses a specific mechanism, the specific mechanism of using a translation matrix, where the point moves across the screen horizontally, and then the frames are generated based on the movement of the point. And then the 14th and 15th paper here again also detect object. So let me just extract the image from the video, and the object detection algorithm is applied to provide posture recommendations. Immense potential for improving sitting posture. Right. The 14th paper is based on and analyzing the sitting posture of the user, and is not particularly for yoga or exercises, but again very relevant to our research. Now, real-time yoga pose classification, again, the 15th paper is based on research on yoga exercises. Now, the discussion here is although there are accurate or good amount of accurate research articles out there, feedback is still that is something lagging in this field. And then that can be incorporated by the integration of wearables like your smartwatch or stuff like that. And then that also could be incorporated into further research. Now, conclusion, um, like I mentioned, feedback should be integrated. Plus, the future research should also integrate multimodal data, which is not restricted to just the video that is being captured, but also RGB, depth, and biomechanics. RGB is essentially the red, green, blue, which means that the color video is also being incorporated, so as to provide more accurate feedback to the user. Scalability and affordability are also something that should be taken into consideration as your application grows and there's more users that are using your application. How does one ensure that does not come into the way of accurate feedback being proposed to the user? So all that also has to be taken into consideration, and there's still a lot of scope for research in this field. That is what I'm trying to convey here. And then for the references, I've included all the 15 papers that I've chosen for my research here. That's it for the presentation. I'm open for questions now.
Thank you so much for your presentation, sir. Now we'll be taking our next presenter for the session. Our next presenter for the session is Prachi Rawat, presenting a paper titled on the topic Comparative Analysis of Deep Learning Models for Speech to Text and Text to Speech Conversation. So conversion. I request you if you're available, please kindly
Yeah, I'll
start
share
with
my
the presentation.
screen.
Okay.
I hope my screen is visible.
Yes, ma'am, it is visible.
So the title of our paper is Comparison of Deep Learning Models for Speech to Text and Text to Speech Conversion. Our paper ID 721, and I'm here with my co-presenter Razia Landke. So I'll start with the introduction. Speech to text and text to speech are technologies in natural language processing and human computer, and they play a crucial role in virtual systems. So I will ask Razia to go forward with the literature survey.
Yeah, so this is the literature survey we did for writing a paper. We have gone through several papers and studied them well so as to uh, study all the models for existing models for speech to text and text to speech conversion. So this is the first paper, which is about planning the development of text to speech synthesis models and dataset with dynamic deep learning. From each paper, we got some inputs of the models which are currently being used for the conversions. So we have listed the algorithms which are used in that particular paper and the advantages, limitations, and also the applications in which those models are used. So the first one is used for text-to-speech system for accessibility, education, and assistive technologies. And the second paper is used for automatic speech recognition, speech identification, emotional speech recognition, and speech enhancement. There are limitations listed for these papers as well. Next slide, please. So this is the third paper, which is about design and implementation of text-to-speech conversion for visually impaired people. So the algorithms used were about natural language processing, a digital signal, that is DSP, and the advantage of this paper was this paper enhances accessibility for visually impaired people, support multiple languages and domain with customizable synthesis. And the fourth paper was deep speech to end-to-end speech recognition in English and Mandarin language. Next slide, please. So this is all about literature survey. We have listed all the 6 papers. Um,
So now I'm going to give a brief review of the speech to text models which we have studied. So the first model which we have studied is Whisper. It was developed by OpenAI in 2022, and it is a transformer based automatic speech recognition system. It supports 99 languages, and it is extensively trained on 680,000 hours of audio. And we can also fine tune it on data sets like LJ speech dataset, and it handles accents, contextual variations, and noise pretty well. The model size is 39M to 1.55 billion parameters, and here we can say that larger models have more computational cost. Its word error rate is 8.06%, and it is a little higher than the word error rate, which should be like the word it should be 6, but it is 8.06. So if we want to increase the precision of this model, we can fine tune it more on data sets which are there. So we need to fine tune it. It is used for multilingual transcription, and the reason why it is used more than the rest of the models is that it acts very uh, it is very precise in natural sounds, like when there is noise, like we have traffic sounds, we have like background noise like music, etc. Other challenges in this model are that it lacks real-time transcription, and it requires tools for fine-tuning for domain-specific tasks. So let's see the workflow of this model. So first of all, voice detection, then it recognizes the language of speech, then it extracts the feature, and it is basically encoder decoder architecture, and then speech to text conversion. So this was the first model which we have studied. The second model which we have studied is Deep Speech 2. It was developed by Mozilla in 2017, and it is inspired by Baidu's Deep Speech. It uses deep neural networks plus n-gram language model for accuracy. This one also supports multiple languages and platforms. Uh, One of the limitations of this model is that it has a 10-second audio limit. That is, it will only recognize the clips which are of 10 seconds. So it will be a kind of a challenge to fine tune this model on the data sets which are there on Kaggle. We need to like develop our own data set, and it struggles with continuous audio. It performs well in dictation, but it is less effective for podcast and meetings, as it doesn't handle background noise very well. It doesn't work that well in natural environments. Its applications are speech to text for short recordings and voice commands. Challenges is small corpus size, the same thing, like it has a 10-second audio limit, and if we want to pass more, we have to basically split the sentence. So let's see the workflow of deep speech. So first, pre-processing of data, that is splitting audio into 10-second chunks. Then feature extraction, then it passes through a deep neural network. Then then N language model integration, post processing, and then we get the transcribed text. The third model which we have studied is Wave to Vec. It was developed by Meta for low resource languages, learns sound like tokens instead of full text speech pairs. It requires 50% less data for fine tuning than traditional automatic speech recognition systems.
Sorry to
100
disturb
times.
you, ma'am. We have crossed the time limit of 7 minutes criteria. I request you to kindly conclude your presentation at the earliest, please.
Okay, okay. So it requires 100 times less training data, and it outperforms the rest of the models. It also supports 40 plus languages. I'll move to the next model. Caldi. Caldi is an open source model, and it is unique as it is developed in C++. It uses generic speech data. It is highly customizable, and it has cross platform support, that is for desktop, Android browsers. And so I request Razia to go ahead with the
Yeah,
text to speech models.
as similarly, we did a study for text to speech models. So the first one is DeepGram Aura. It is developed by DeepGram. It's a cutting edge TTS model, and it is optimized for ultra low latency. It has adjustable voice and emotional dynamically based on conversational context. This is the main task of a DeepGram Aura model.
So the application include customer service, education, and AI voice assistant. Challenges include slight trade-off in voice quality for speed, accuracy, and in noisy environments. This is the workflow of the DeepGram Aura. Next slide. So second model is Google's text-to-speech model. It is developed by Google, and it's an open source model, user-friendly for TTS tools, and it focuses on clarity and ease of use rather than naturalness. So applications include audio-based learning tools, public announcements. Challenges includes limited emotional variance, it struggles with complex speech synthesis. This is the workflow of GTTS model. So the third one is Stackathon 2. It is developed by Google in 2017, and it produces a near human speech, like it actually sounds like a human is speaking. It has high naturalness. That is the main advantage of Stackathon 2, and it is ideal for virtual assistants. And the application includes conversational AI, interactive voice response, and
Sorry to interrupt. We have crossed the 10 minutes mark as well. We request you to kindly conclude with the presentation at the earliest.
yeah, then continue. Next slide, please. And this is the last model, which is FastFish 2, developed, and it is developed by Microsoft, and it is ideal for real-time applications like voice services and chatbots. So this is the comparison of STT and TTS models. We did comparison on the basis of the primary languages, strengths, key features. This is for STT models. Next slide. So features are training approach, deployments, and then use cases. On basis of these features, we did comparison of different models so as to get an insight of what each model has. Similarly, we did for TTS. Next slide. These are the references which we have used for models.
So we would like to conclude our presentation with this. Thank you so much. I'll stop sharing.
Thank you.
Thank you so much. Before we begin with this next presentation, I would like to introduce you all to our session chair, Dr. Vinod Ray Tomar. Sir, would you like to say a few words before we get to the next presentation?
Thank you so much for inviting me. You can carry on for the next presentation.
For sure, sir. Thank you so much for being with us, sir. Now I'll switch on to the next presenter. Our next presenter is A. Kausar Nikhat, presenting on the paper titled Deep Learning Model for Lip-Based Speech Synthesis. I request you to kindly start with your presentation, ma'am.
My screen visible, ma'am?
Yes, ma'am, your screen is visible.
Yeah. Good morning. So this is our team, followed myself, Kausar Dikhat, with our students Raman Teja, Anchal Jain, and Ananya, who are working on the deep reading ML model for forensic analysis. So in today's world, where we are having so many deep faults in persons analyzing their work and their analysis of the lip, and also there are many fake videos getting generated in the YouTube content and all. So this proposed system, which we have done with the AI driven lip reading analysis system, will be able to tailor for the law purpose, for forensic analysis, for investigations, and providing this evidence in order to analyze who actually is the person behind the movement. So by combining the computer vision and natural language processing, our approach will also has achieved a good accuracy in challenging the real world scenarios. So we have analyzed the lip movements, the gestures, the angle, the textual transcripts, and also the video frame bits which the content the persons have talking during the process. So we have taken the video bytes as an input and then processed it into frames, and then by applying deep learning techniques, we have tried to do the model development. So, and this innovation approach will be able to provide and enhance this investigative capabilities, will be able to give a good resolution, and also immense has a good video footage. If it is given as an input, will be able to analyze even in the worst scenarios, and also to track out which video is fake and which video is not a fake video. Because most of the people, when they do the augmenting or fake doing try to do the faking of the available videos or available cine actors or the one, they try to only copy the image, but the lip movement, by observing and by analyzing the lip movement, we can easily be able to find out whether that particular person is genuine or not. So our AI powered lip uh, reading framework will be able to specifically meet with these such a kind of requirement. We can sort out which is a person genuine and not a genuine person. In the existing systems like DeepLink, LipNet, and Read My Lips, we are having few is focusing on speech, few is focusing on the particular model, and few is restricted to with some limitations. Like there is some diverse conditions. Some is having the variance in this voice. Some is having the prior training data limitations. Some is not going, not giving a good contextual speech or the appropriate voice for the given input. Lip movement and all is not matching with what the person is talking, or there is also a bias in the gender. So all such things are being there restricted in the deep link and all these things. In the proposed system, we all have tried to overcome these concerns like accuracy, the gender bias, the variability, the speaker, the modem of the what tone that particular person is talking, and all. So this is our architecture where we have taken the input as a data set, and we have trained it, then generated the output and done the results. I think even if my students are there, even they too can continue. They can join with this. So here we are doing the machine learning model, which is being done, and also done the interpretation, and then we are analyzing the output. So this is how the input is being run in the model, where the video is being generated, and then this is how the video is being analyzed with these by converting it into a grayscale and then trying to make into RGB and all. So this innovative noise reduction method will not only preserve the what do you say, the accuracy of how to interpret the face gestures and also, but will also be helping in the forensic analysis and readability. So this is how the data collection is done, and the feature extraction, sequence modeling, then training, and then the results. So for this, we have taken the libraries or like TensorFlow, Keras, and so on. This is a simple scenario of how we get the result of a simple lip movement, which is being done from the above video. Even in this, the video which is being converted into the form and then being generated. Maybe my students can also add on for the things. Hello, are you there, ma?
Yes,
Yeah.
ma'am. We would like to continue from the previous slide. So the next slide, ma'am. The next. Yes, so this is the part of the code wherein we inserted the code line such that the video which is given as an input into the user interface will be taken into the machine in this form. So this is the way in which the machine interprets the user's lips. And the machine and the model is set in a way such that it could identify the area wherein the user's lips are are the main focus through which we can identify the words which are spoken by the user. So this is the main part of our model, which is able to make it through this research paper. And the next slide, ma'am. Can you please move to the next slide, ma'am? So here, at the top, the choose video option is there, wherein through the down icon, we can select the video which we want to give in as an input, and then the video is generated by the model. And the right hand side top video uh, is the area which the model takes in as the input, and the raw data is given out as the output by the model. This is how our model works, and that's it. I hope you like it.
Yeah, thank you for giving the opportunity.
Yeah, thank you.
And we are also thankful to college, VNRDJT, for providing this opportunity. Thank you.
Thank you so much, ma'am. Sir, do we have any questions for their presentation?
Yes, I have one question. I would like to ask you that you have used videos as a data set. So is it possible for each and every different file formats of videos? Or is there any specific file format?
Yes, it is possible, but right now the machine, we have given all the MPG format videos as an input.
MPG only right now.
Yes, for now.
Okay.
We can obviously get
Oh,
in.
means you can do the testing for another file formats also.
Yes,
Okay, okay, good. Thank you.
thank you.
Next presentation, please.
Yes, sir. We'll switch. We'll go for the next presentation. Our next presenter is Randeep Sinclair, presenting the paper on the title Exploration of Galactic Redshift and its Impact on Galaxy Properties Using Machine Learning. If you are available with us, I request you to kindly take over with your presentation, please.
Yes, ma'am. Am I audible? And
Yes, sir, you're audible. I'll stop sharing.
just
Yes.
give me a moment. Is my screen visible?
Yes, sir, it is visible.
Yeah. Good afternoon, everyone. Very warm good afternoon to all the fellow researchers. I, Randeep Singh Kalay from Lovely Professional University, is going to present my paper on exploration of galactic redshift and impact on galaxy properties using machine learning. The paper ID is 711. Now, first things first. What is redshift exactly? Now, as we all know, our universe started with a Big Bang. Ever since that, the space in between the galaxy is expanding. The space itself is expanding at a very exponential rate. As Hubble's law dictates that the velocity at which the galaxy is moving from an observer is directly proportional to distance, which in a nutshell means the faster the galaxy is moving, the larger the distance, the gap will be between the observer and the galaxy. Now, as the space is expanding, the wavelength is also increases. The light coming from the electromagnetic radiation coming from the other galaxy that we are observing on this planet Earth are appearing to be on the red end of the visible spectra. This red tint or this red color observation of this galaxy is called redshift in astrophysics. Now, coming on to the next slide, I have taken this slide from the NASA website, and it is provided by the Hubble telescope, and it is present in the public domain as well. Now, as we all can see that 13 billion years ago, our universe looked like this, a bit cluttered. The galaxies were not mature yet. They were in different forms and shapes, like they were not in elliptical or spherical form like our Milky Way galaxy is. Now, as the time progresses, like 13 billion years ago to 10.7 billion years ago, the galaxy starts to mature a bit. The star formation rate the merger rate, the exotic materials starts to reduce, and the galaxy becomes more and more mature. Now, considering the 13 billion years ago image and the 0.5 billion year ago image, there is a stark difference. As we can see, the galaxy here is quite mature, but in this case, the universe is quite at an early stage. That means that universe is quite young. So all the exotic material present in between the galaxy for the formation of stars and planets is at a very critical temperature. Now, there are multiple methods to calculate redshift. The traditional method is spectroscopy. Spectroscopy is based upon spectral energy distribution. In a nutshell, it means that it analyzes the spectral lines of a galaxy. For example, if something is charged and it is moving, it is quite obvious that it would emit some sort of electromagnetic radiation. Now, these electromagnetic radiations falls in different level of wavelength of visible spectrum. Now, as we can see that in the very distant galaxies, let me zoom in a bit. Uh, in the very distant galaxies, these spectral lines, the black lines, are falling on the red end of the visible spectrum. That is why we observe the galaxy which are very far away from us in a very red colored tint. On the other hand, the galaxy which are quite close to us, that are quite close to Milky Way galaxy, the spectral lines on these are falling in between the purple and the blue region, which signifies that they are very close to us in terms of distance, in terms of light year distance. Now, the second method that we use to calculate the redshift is photometry. In photometry, what really happens is that there are different, it essentially means that we are measuring the brightness of a galaxy in different filters. Now, the filters would be ultraviolet, infrared, optical, green, red. It's just like you are wearing a sunglasses of red color, green color, or black color for that matter, and you are observing the things around you. So, as per the filter, as per the colored glasses that you are wearing, the things would appear in that color only. Now, there are some challenges in traditional method, that is in the empirical method, spectroscopy method. It's quite time consuming and it is very resource intensive. Like a lot of uh, heavy telescopes are required to observe these galaxies. But on the other hand, the photometry uses simple broadband fluxes, broadband filters to measure the galaxy brightness in different wavelengths. And there are also some observational constraints, like there are certain places from which there are only certain places from where we can observe certain galaxies. But on the other hand, photometry can work under varied conditions as well. Like for the very distant galaxies as well, it can work. As it is mentioned that limited sample size, only the galaxies that are very close to us, spectroscopy will help in that. But photometry can reach the faint and the distant galaxy, which again means that the galaxies that are very far away from our galaxy can be observed through photometry, and their redshift can be calculated in the same way. Now the machine there, although there are n number of machine learning algorithms, supervised, unsupervised, reinforced to calculate redshift, but our review focuses on the supervised end of the machine learning for calculating the redshift. The algorithms that we have used or reviewed essentially read for random forest, support vector machines, gradient boosting machines, artificial neural networks, k nearest neighbors, kernel regression, self-organizing map with convolutional neural networks. Now, there are certain state-of-the-art technologies as well. Now, for example, this sheep pipeline is dedicated for astrophysics to calculate redshift only. Now, we take some photometric data. It can be from any data set. For example, there are multiple data sets that we use like SDSS dataset, Cosmos band, deep dataset, and dataset can be from any source. Reprocessing and done reprocessing processing of the data is done on that like any missing values or any erroneous values are reduced or removed altogether by machine learning technologies. And then some gradient boosting algorithms are used, like XGBoost, LightBoost, and Cat Boost. Average of those voting is taken out and a prediction at level 1 is created. Then to refine that prediction, a chain regression is used. Chain regression will involve certain linear regression models or kernel regression and support vector regressor to further enhance the prediction to further reduce the error in that. Now, in the final stage at level 2 prediction, there is a multi-class classification. This means that we essentially differentiate between what type of celestial objects that we are studying. Like there are many celestial objects, like there are galaxies, there are black holes, there are stars, there are exotic matters like dust and all of that. So multi-class classification is used to identify between to differentiate between the uh, celestial objects. Now, these were the performance of the models that we reviewed. Now, this is the bar graph of that, and these are the detailed performance metrics like RMSE, MSE, and R square, which explains the variance. Now, as shown in the result, the best model that performed was the kernel regression. The reason it performed was because it was able to map high dimensional data, and it was able to understand the high collinearity between the input features as well. Now, the model which really struggled was the k-nearest neighbor. Although it is a good model for simple and linear regression tasks, but when the dataset is having high dimensionality, high input features, and the collinearity between the input features is quite high, it struggles in that. Other models also performed fairly well as compared to k-nearest neighbors, because all these models have their own USPs in handling high dimensionality data as well. Now, as an example, the Sloan Digital Sky, we reviewed the Sloan Digital Sky dataset, and it was the last year's latest release, that is of 2024. And we calculated a correlation matrix in form of a heat map. Now, as we can see that these bands like U, G, R, I, these stands for ultraviolet, green, red, infrared, and so on. All these bands are highly correlated with each other. So it means that if one band is affected, the others will also get affected a lot. Like the correlation is quite high in that, like 0.95 with R and U. And with Z, we are having a high correlation with infrared band as well in 0.88. Last but not the least, we also reviewed a study which involved variational autoencoders and hierarchical clustering to classify between the morphology of the galaxies. Now, in simple terms, it means that beyond a certain redshift value, that is beyond z greater than 2, we reviewed that the galaxy, like in the table set 1.1, 1.2, 2.1, and 2.1.2, 2.1.3. The galaxies are quite symmetrical, and they are having active star formation rate, which means that the galaxy beyond this region were young in nature. They were not that old as compared to our Milky Way galaxy. The star formation rate and the merger rate in these galaxies was quite high. But there is also a stark comparison between other groups as well, such as in group number 2.2.5 and 2.2.3. The galaxies are mature here, but one might argue that the value they are having is beyond 2, right? So why are they stable in nature? They are not as why are they spherical, or why are they not regular irregular in nature? So this just concludes that the galaxies beyond a certain value of redshift are very irregular in nature. Some of the galaxies, but most of the galaxy will be having a active star formation rate because of the exotic materials. Some of the galaxy will be having high merger rate. some of the because of the activity of hydrogen and helium in between them. But some of the galaxy would have been matured, like they would be having a low star formation rate, low exotic material, just like our Milky Way galaxy.
Sorry to interrupt, sir. We have completed the 8 minutes mark. I request you to kindly conclude as soon as possible.
Yeah. Now, all of this study concluded that the redshift beyond a certain value shows high irregularities in the galaxies. Not even in the galaxies, but in the black holes and stars as well. So this concluded my presentation. I am open to any questions, if any.
Yes, I have one question for you.
Yes,
Uh,
sir.
you have implemented your work in a different machine learning algorithms in which you have told that you have achieved the best results in kernel regression, right?
Yes, sir. We reviewed a paper that showed that the best results were provided in kernel regression. Yes, sir.
Okay. So what is the accuracy of your work in this algorithm?
Yeah, the study that we reviewed, sir, provided a variance of 99.3%. Like it was able to explain a variance of the data, that is the data spread over the best fit line was 99.3%. And even the RMSE is also quite less in this case, like it's 0.0189 as compared to all the other algorithms,
Okay. So tell me,
which were
is there any limitation of kernel regression?
no, as of now, the kernel regression performs the best. The limitation would be a slight disadvantage is that it requires high computational power. Like it requires strong GPUs. It won't work on a simple laptop. It would require high GPU processing power to, calculate the high dimensionality datasets. That would be the
Okay.
only drawback of this algorithm, as far as I can see. Other than that, it is very good as to map the high dimensionality input features and in terms of feature selection as
Perfect. Okay, good. Thank you.
well. Okay, thank you, sir.
Thank you so much for your presentation. Now we'll call upon the next presenter.
Thank you.
Our next presenter is Kavita Guddad, presenting a paper on the title Innovative Bow Tie Antenna Design for Enhanced MRI Imaging. If you are available with us, ma'am, you can take on the screen.
Yeah, yeah, Prashi.
Okay, ma'am.
Just a minute. I'll share my screen. Can you please ask the previous person
Uh,
to?
yes. So,
Yeah, I'll share.
Mr. Singh, I request you to kindly stop sharing the screen, sir. Okay. Yes, ma'am.
Yeah, thank you. Hope my screen is visible.
Not
Can you
yet,
please?
ma'am. Now it is visible.
Yeah, thank you. Good afternoon, everyone. Myself, I'm Kavita Guddat. I'm from Ryan Sagar College of Engineering, Bangalore. Today, I'm here to present our work on bow tie antenna titled Innovative Bow Tie Antenna Design for Enhanced MRI Imaging. My paper ID is 670, and my co-authors are Dr. Sudha KL and Mrs. Navya Holla K. And my presentation is going to cover all these points: introduction, literature review, I'm sorry, design and implementation process, simulation, fabrication, and conclusion, along with references. So coming to first, what is bow tie antenna, and before that, what is MRI, and also how both are related to each other. So a bow tie antenna is a type of antenna which construction-wise it has two triangular elements which looks like a bow tie, so it is called as bow tie antenna. And its qualities make it to be used in MRI applications because of its broadband, then it is able to withstand the high power versatile design, which makes it to be used in many applications such as radar, and communication systems, medical imaging, everywhere. Hence, it is used in MRI systems also, as per the literature review we have done. So it has very good radiation efficiency, and it has a good reception qualities, because of which it is suitable. It's assumed it is suitable for MRI systems. So it can be operated in different frequency ranges. Also, it has a very good bandwidth, and the most important thing is its capability to design to give different types of radiation patterns, right from omnidirectional to directional antenna patterns. So, coming to MRI, it is already known to everyone. It is magnetic resonance imaging, which is used in medical fields for scanning the body, which is a non-invasive method and which is better compared to in particular cases, especially compared to X-rays. So, as X-rays are use ionizing radiations, but MRI uses non-ionizing radiations, so it is more safe compared to other scanning mechanisms. So in MRI, where the bow tie antenna is used, that is the one thing we are supposed to understand. As MRI uses RF signals to perform the medical imaging, so we need a RF antenna. So in that place, we can use MRI for bow tie antenna for both transmission as well as reception. Sorry. So, the objectives of this particular work are the intense literature review and design and fabricate a bow tie antenna, which is basically used in ultra high field MRI applications, which is intended to use, not which is used, intended to be used in ultra high field imaging, MRI applications. So the specifications we have taken is 10.5 gigahertz, and we expect the antenna to behave with these properties. That is, the antenna is expected to have a 2 dB gain and the minus 10 dB of reflection, the reflection coefficient of the loss, reflection loss, you can say. So it is operating in the X band region. Coming to the literature review has been done by keeping into mind the many aspects, such as the different types of antennas used in MRI as well as in medical fields. Then, with respect to patients' comfort, as well as with respect to the gain and SNR, as well as the SAR aspects when coming to the antenna. So in that regard, we have reviewed so many papers. A few of them I just try to explain here. Otherwise, they are related to each other anyhow. Okay. So a paper in 2023 which presents a dual band antenna which is operating at 2.4 gigahertz, which focuses on the specific frequency characteristics which support MRI antenna. So basically, I'll just take it in a little bit next slide. Basically, there are three MRIs commonly used in applications in the labs, actually, for the purpose of MRI imaging. But the researchers have tried to identify these possibilities of using different kinds of antennas. So when we did a literature review, we got all these specific antennas for specific kind of applications. So in that regard, the second paper, which is published in 2022, operates at 5 gigahertz, which is a planar antenna, and which is also used for high resolution MRI. So similarly, the papers in 2010, which are again 5 gigahertz microstrip antennas, okay, for head imaging purpose, which are suitable for head imaging purpose. So similarly, the paper in 2018, which says design of a flexible microstrip antenna, which is tailored for MRI applications. Again, it's a flexibility means it is designed by keeping into mind the patient comfort. Then similarly, there is a paper which is a publication which designs a 6 gigahertz antenna, which is wideband surface coil antenna, which is optimized for high field MRI. So I'll just a little bit later I'll let you know what is meant by high field, all those things. Okay. Similarly, in 2021, there was a publication which is designing a 6 gigahertz microstrip antenna. Means all these papers will tell there are different antennas used in MRI applications, but among them, the bow tie antenna is more better compared to other antennas because of its important properties just discussed before. So the last two papers again are based on the bow tie antenna, and the last but one paper was the motivation for us, which is designing a 10 gigahertz bow tie antenna. But we tried designing it as well as fabricating it and testing it in the anechoic chamber. So similarly, the other set of papers which were based on MRI applications only, but they were using different types of technology of antenna, that is array configuration. As we know already, the array configuration gives us better gain and the radiation patterns by this basic study already. So these papers emphasize by using the array antennas, again they are specifically designed for a particular kind of applications like knee imaging or again in MRI only. But they can give you better image quality as well as better uh, uh, details about the body parts. So this by using the phased arrays. And the other set of papers which were emphasizing the patient comfort during the MRI imaging. So they are nothing but the last two papers which were published in 2023, a 3.5 gigahertz bow tie antenna designed for brain imaging. So it was made flexible to be wore as a cap on the head. So in
Sorry
that
to
one,
disturb you, ma'am. This is a gentle reminder of the
okay,
8 minute mark completing. I request you to kindly conclude as soon as
yeah,
possible.
yes, ma'am. So all these literature review made us to design a bow tie antenna with a set specifications which are helpful for the MRI applications. So these are the available antenna, sorry, MRI systems which I told. It's 1.5 Tesla, 3 Tesla, and 7 Tesla, which are most commonly used in MRI imaging in the medical field. But there are specialized MRI imaging systems which are called as 9 Tesla and 11 Tesla also, but they are not for the common usage, but they are for the particular specific usage like a clinical research or small animal imaging and all. So there were few challenges in designing the bow tie antenna. So with respect to choosing a dielectric material as well as design and optimizing them to get the required specified, required behavior. So in that regard, we just did a survey with respect to dielectric constants also. So sorry, I mean which is property of a dielectric materials used in the antennas. So and we choose based on these properties. The These are the few dielectric materials used by the literature, and in that we have used the PLA, that is polylactic acid, as it is suitable for the high frequency ranges. So this is the design constraints. These are the design mathematical basics from the antenna textbooks, and these are the values obtained by using our dielectric constant as well as the required frequency. So and because of the PLA, we are taking epsilon r, that is related to radio permittivity, as 3, and we will get the wavelength of lambda is equal to 0.0285 for the frequency 10.5 gigahertz, which is our expectation. And based on that, we get the dimensions of the antenna and also the gap between the two elements as well as the feed gap which is required to simulate in the system. We use HFSS simulation tool to simulate this particular aspect, and then we tried to fine tune it to get the required uh, radiation pattern as well as the gain. And these are the results of simulation in HFSS. The first one is the 3D radiation pattern, second one is the E plane, and the third one is the H plane radiation pattern. So H plane radiation pattern shows its omnidirectional kind of behavior. And this is a reflection loss graph. which says that at around 10.5 gigahertz, we are getting the minimum reflection compared to any other, which is the most important thing for the application we are designing for. And these are the pictures of the fabrication, which is done using PLA as substrate and the copper as the conducting material by using these dimensions. And third one is the testing picture, which in anechoic chamber, and the results of testing, the pictures obtained for radiation pattern as well as reflection loss by using the anechoic chamber testing. So this is a comparison of the two, the simulation through HFSS software as well as through the anechoic chamber readings. So both the comparisons show that the designed antenna behaves to the maximum extent to the expectation. That is, it resonates at 10.5 gigahertz and it has a minimum reflection coefficient at or reflection loss at 10.5 gigahertz, and it has got a omnidirectional radiation pattern in H plane. So the conclusion is the bow tie antenna has uh, versatile capability, which makes it suitable for the MRI imaging, and the designed antenna can be used in the ultra high field MRI applications. And by combining this in the form of an array, we can further enhance the capabilities of this antenna for the MRI applications. So these are the references I have used. Thank you. I'm open to any questions. Thank you, Prashi.
Thank you so much, ma'am. Sir, do we have any questions for ma'am?
No, we will move towards the next presentation.
For sure,
Thank you,
sir.
sir.
Thank you so much for presenting,
I'll
ma'am.
stop my sharing. Thank you.
Yes, ma'am. Now we'll go to the next presenter. Our next presenter is Bharati B. Paniyogi. I'll just read out the paper title. The paper title is Integrating Federated Transfer Learning and Blockchain to Enhance IoT Security, a Comprehensive Survey. If ma'am, you are available, I request you to kindly take over the session with your presentation, please.
Okay, ma'am. Thank you.
Thank you so much.
Am I
Ma'am.
audible now, ma'am?
Yes, ma'am, you're audible.
Okay. Okay. Is it my screen is visible, ma'am?
Yes, ma'am, now the screen is also visible.
Okay. Good afternoon, everybody. Uh, myself is Dr. Bharti Pannagol, and my co-authors are Santosh Deshpande, Rohit Kaliwal, and Bharti Chillat. Today we are presenting a survey paper on integrating a federated transfer learning and the blockchain to enhance the security. So these are the contents. These are the contents. Let's begin with the abstract. So here, the federated learning, it will enhance the IoT security by enabling the decentralized model training without sharing any sensitive data. While the blockchain, even it will also ensure the data integrity and the trust through its tamper-resistant ledgers. So here we are seeing how the integration of federated learning and blockchain can be done to improve the privacy and the security for the IoT devices. So that survey we have performed here. Let's begin with the introduction. The IoT, that is Internet of Things, it is a networking of a physical object which will contain the electronics embedded within their architecture in order to communicate and sense the interactions among each other. So we can say that the IoT, it's a device which will allow to communicate with the applications and the resources at any time, anyone, any services, to view the any services by using any path at any place by using the anything. So the top IoT applications are like we can use the IoTs in transportation industries, markets, schools, vehicles, smart homes, agriculture, healthcare. These applications are not restricted only for this. There are many applications. So as per the survey which has been done by the Statista, we can see that at the 2024, the number of IoT devices connected The range was 17.08 billion, but they have expected at the end of 2030 it may reach to 29.42 billions. Then the background. Here first we will see what do you mean by federated learning and what are the different types of federated learning. So here the federated learning, it is a revolutionary implementation of the machine learning methods which will let the several devices to develop a model while keeping the input data localized. So three types of methodologies are there: horizontal, vertical and federated transfer learning. So in the horizontal, they have used the type types of data like clients with a comparable feature space, but distinct samples will be involved. Example, many hospitals uh, they may have the patient data with the same age, symptoms, etc., but of the different people. So it is going to help to facilitate the medical related applications. Vertical federated learning, in this, the customers have the various feature sets, but for the same samples. Example, a bank and the hospital, they may want to collaborate on a medical history to predict the patient's credit risk. So the bank has the financial data while the medical has the health related data. So the same person's bank related data and the hospital data, this data will be shared among the bank and the hospital. Then federated transfer learning, it is going to mix the transfer learning and the federated learning. Then next are the applications of the federated learning. The applications of the federated learning, it can be used in the healthcare so that they can implement or build a predictive model using the patient's data without compromising the privacy, and they can enhance the diagnosis and the treatment by aggregating the local data from the multiple inputs. Then next is the finance. So they want to improve the fraud detection system by training the model. Then next, Internet of Things, by teaching the IoT devices to learn collaboratively and improve the anomaly detection and optimize the smart devices. Here also without compromising the user data. Natural language processing. So here the federated learning, it is going to facilitate training language models based on the user preferences and the dialects, which will enable the businesses to enhance the customer service chatbots while protecting the proprietary text data. Then next is autonomous vehicle. In this, the vehicles are going to share the road condition insights using the federated learning without sharing the sensor data. Only the insights data will be shared here. Retail and the e-commerce, here the customer can build a system uh, to create a they can build a system, or they can use the federated learning to create a behavior based recommendation system so that they can optimize the product suggestions and production. Telecommunications enhance the network performance by jointly training the models on the user data. And next is in the smart cities. Smart cities, it is going to support the and it is going to support the smart city initiative by enabling the data driven from the multiple sensors, so that the municipal planning allowing agencies to analysis the office energy public safety data without compromising the sensitive data. Then how this federated transfer learning is going to work? Initially what happened, the client a client is going to get registered with the server. Then once the all clients will be get registered to the server, server is going to send its global parameter to the each server. After getting this global parameter, the each client is going to initialize its local parameters, and he is going to train its local parameter based on its local data, and they are going to prepare a model or the gradients, and these models data or the output gradients only shared to the server. Then the server, he is going to aggregate all the models from all the clients, and he is going to, at the end he is going to generate one global model there, which can be used for the application. So this process will be continued. Then next, the advantages of federated transfer learning. There are many advantages. in the federated transfer learning, like data privacy and the security, in utilization of the diverse data sources, reduced communication cost, adaptability to a different task, improved model performance, faster coverage, scalability, support for the non-IID data, collaboration across the organization, and improved learning with a little data. Then next, we have done compared the federated transfer learning with the machine learning and the federated learning by some aspects like data handling, learning paradigm, model training, application, and the challenges. Where with respect to the data handling, machine learning, they are going to concentrate on the centralized data storage and resist the privacy concern. Where the federated, it is going to work on the decentralized manner, but data is going to remain on the local devices. But in the federated transfer learning, data stay local, knowledge from the from the predefined model is utilized. Learning paradigm, single task learning will be then, and it will require a large data set in the machine learning.
To
Federated, it
disturb
is
you,
going.
ma'am, we have
Sorry.
completed our 7 minutes criteria
Just
mark. I request you to
okay.
kindly conclude as soon as possible. Thank you.
Okay, sir. Okay. Then next is, and we have performed the analysis of the federated learning and the blockchain in providing the security. So here we have performed the survey around 8 pages, and we have compared. We have surveyed what are the advantages and disadvantages and which all methodology they have used. So in the first paper, they have implemented the FedRest. Here they have made use of the federated, defederated learning. Okay, the advantages is it has reduced the computational burden, enhanced the detection of the malicious node, and it is going to support for the then but the trust parameter management is complicated and may need significant resources for the large scale use. Next paper, here they have provided the trust, simplifies the resource management and secure the model parameter exchange. But it is possibly implementation complexities are present, and there is a overhead with a restricted resource. Then in the next paper, it is outlined the probable challenges and presents one complete taxonomy and suggested some additional researches. But here there will be only few choices are will be existed. Next is they have detected the abnormalities privately, stream accurate outlier detection using the bandwidth efficiency. But federalized learning may be difficult due to the high quality local data. Then next is next paper. They have protected the sensitive data, perform the performs the better with the multiple data and resist to the attack. But aggregation model requires the prudence here. Then in the next paper, the work enables the collaborative training on the diverse devices, ensure the privacy performance. But here the challenge is the limited activation function and security concerns in the model aggregation. Next is privacy preserving tiny machine learning tech concept as used. But the problem is that the enhancement includes the better weight decays here. Then the last paper, it will enhance the computational power and improve the security and the privacy, and even it will increase the system efficiency. But transfer learning may enhance the performance, but the accuracy remains will be little here. So we can conclude here the integration of blockchain and federated learning, they are going to offer a robust solution to enhance the security in the IoT devices. So this collaboration, it will mitigate the risk associated with the centralized system, as the both the concept they are going to work on a decentralized manner, and the findings highlight significant improvements in safety and performance we have highlighted here. Thank you. Thank you, ma'am.
Thank you so much for your presentation, ma'am. Sir, do we have any questions for ma'am?
Yes, I would like to one question that you have done a comparative analysis regarding federated learning and blockchain
Yes, sir.
regarding IoT security. Okay,
Yes,
so
sir.
my question is that which feature of blockchain technology is used in your comparative analysis to enhance the IoT security?
Sir, here we are using this in my objective. We are using this blockchain to find the malicious nodes in the IoT devices for the classification, and after classification, whatever the genuine device is there for storing. So smart contract and consensus algorithm we are implementing here. So
Okay, means you are going to design a smart contract. Through smart contract,
yes,
you can. Yes, fine. Good.
yes, sir. Yes, sir.
Okay, good,
Fine.
good. Dear moderator and dear participants, I would like to request to allow me to leave this interactive session as I have some important meetings right now. I would like to thank you all for giving me an opportunity to interact with you. But due to some important meetings, I have to leave this session. Thank you. Thank you so much.
Thank you so much, sir, for joining us. We'll
Thank you.
continue with our presentation. I'll be now calling on the next presenter. Our next presenter for this session is Rajput Aditya Singh Shashikant Singh. He's going to be presenting a paper on the title Power Electronics, a Pivotal Role in Strengthening Cybersecurity. If you are available with us, I request you to kindly take over with your presentation, please.
Just a second, let me share my screen.
Okay.
Good afternoon, everyone. I am Aditya Singh Rajput, and today I will be discussing how power electronics plays a crucial role in strengthening cybersecurity. Power electronics is at the heart of modern electric system, ensuring efficient energy conversion, regulation, and control. But in today's interconnected world, securing these systems is just as important as optimizing them. This presentation will explore how power electronics contributes to cyber resilience, safeguards, and critical infrastructure, and enhance security against cyber threats. Uh, let me introduce you to electronics. Power electronics deals with the conversion, control, and management of electrical power using devices like converters, controllers, and inverters. These technologies are widely used in industrial automation and consumer electronics and energy grids. With the rise of smart grids and IoT-driven infrastructures, power electronics has become a key player in cybersecurity. The challenge, the cyber threats targeting power systems can lead to blackouts, financial losses, and national security risks. This is the cybersecurity landscape, which we know. What we get to know about power electronics and cybersecurity, power electronic systems are integral to cybersecurity for sensitive infrastructures, just like we have in ISRO and NASA. Let me introduce you to the cyber security threats in power systems. Cyber attacks on power infrastructure are increasing and they come in many forms. Some ransomware attacks, hackers disrupt the grid operations, some data breaches, smart grids and IoT devices become vulnerable. Grid hacking incidents, the attackers manipulate power flow, causing blackouts. Since power systems are backbone of modern infrastructure, the cybersecurity is in power electronics is no longer optional, it's essential. Let me say how power electronics strengthens cybersecurity. Power electronics integrates advanced security mechanisms to cybersecurity. Power electronics integrates advanced security mechanisms which detect, prevent, and mitigate cyber threats by integrating real-time monitoring, which includes smart sensors continuously scan for anomaly in power consumption, signaling potential cyber intrusions. In dynamic power adjustment, system reconfigure power flow to prevent cyber-induced disruptions. Secure microcontrollers and cryptography. This protect power electronics hardware against firmware attacks. And in AI and machine learning, power systems can predict future cyber attacks and adjust security measures accordingly. These are the some key components of power electronics which we use regularly and which are being used from around 2016 or 2017. Voltage regulators and microcontrollers, which I mentioned below, smart sensors and control systems, which includes sorry, which includes closed loop control systems. Let me share you some resilience strategies. Cyber resilience strategies to ensure continuous and secure operation. Power electronic systems implement some adaptive feedback control automatically, which automatically adjusts system parameters when detecting cyber threats. And for some reasons, securing energy management, which is not being used in India, encryption and authentication prevent unauthorized access, which leads us to get our data breaches. And in machine learning based threat detection, AI analyzes past attacks and predicts future risk. These strategies are not only to protect power system but also ensure minimal service disruption during an attack. Here are some case studies regarding this. We know in real world impact, there are some projects which are running in India right now. There are only two companies which are working on power based cybersecurity threat detection systems. Here are some situations. These strategies are being used. First of all, the smart grid problem. Power electronics isolate affected grid sections to prevent widespread outages. In industrial control systems, we secure microcontrollers which protects factories from hacking induced shutdowns. In IoT devices, we secure boot mechanisms which prevent malware in power connected devices. In wireless communication networks, the power electronics secures communication using frequency hopping techniques. These case studies highlight how power electronics enhances cybersecurity in various critical sectors. Now we will move next to our challenges and their future trends. Despite its benefits, integrating cybersecurity with power electronics, we have to face some challenges. The main challenge is regulatory delays. The standards for power electronics and cybersecurity are not unified. These are the some challenges we have to change and we have to mitigate them. In second word, I can say high implementation cost. Securing electronics require hardware upgrades and advanced cryptographic protocols. To overcome this, we have some strategies to overcome these challenges. We can develop unified standards. we can have accessible, enhanced compliance flexibility, and faster regulatory adoption. For the main challenge which we can face, we can work on the future standardization and policy development.
Sorry to disturb you,
That's
sir. We have exceeded our 7 minutes limit criteria. I request you to kindly wind up the presentation as soon as possible.
uh, just I'm completing it. These are the future trends which we can accept and we can work on. As power system becomes smarter, hardware-based security solution will be crucial for protecting infrastructures. AI-driven cybersecurity for power grids and blockchain-based cybersecurity for decentralized energy networks. The next-gen semiconductors with built-in security features will help us. To sum up, let you all guys see how cybersecurity is including power electronics day by day. To sum, the power electronics is more than just energy conversion. It's a key component in cybersecurity. By integrating real-time monitoring, AI-driven threat detection, and encryption mechanisms, power electronics strengthens the security and resilience of critical infrastructures. With the rise of smart grids, IoT, and industrial automation, investing in secure power electronics is not just beneficial, it's essential. Thank you. I would be happy to take any questions.
Thank you so much for your presentation, sir. Now we would like
Thank
to
you.
move on to the next presenter. Our next and last presenter for this session is Madhura Shankarpure, presenting the paper on the title YOLO Algorithm Based Effective Orange Detection and Localization with Improved Data Augmentation. We request you to kindly take over with your presentation, ma'am.
Yeah, thanks, Rashi. I'm sharing my screen. Is it visible?
Yes, it is visible.
Okay, so hi, good afternoon, everyone. I'm Madhura Shankarpure, and especially I'm working on YOLO with enhanced data augmentation method to improve accuracy. So let's begin with overview of our problem we are addressing. So in today's presentation, we will go through this content. So fruit detection and localization plays a crucial role in robotics harvesting and automated agriculture system. However, accurately detecting oranges in complex environment remains a challenge due to variation in lighting, occlusion, and background noise. Traditional image processing techniques often fail to provide robust results in real-world conditions. To address these challenges, deep learning based object detection model, particularly YOLO, which means you only look once, offer promising results. However, training these models requires large and diverse datasets to improve accuracy and generalization. Our motivation for this research is to enhance orange detection by using improved data augmentation technique to create a more robust model. So the table on this slide summarizes the key contributions from various studies, highlighting their improvements in YOLO-based fruit detection. Several studies have demonstrated the effectiveness of YOLO-based model for fruit detection. Researchers have optimized different YOLO versions to improve accuracy, efficiency, and real-time processing. For instance, lightweight YOLO model have been adapted for mobile applications, while attention modules have enhanced detection in complex orchid environments. Other advancements include orientation bounding boxes for better localization and edge computing for lower latency. These studies highlights a strong trend towards deep learning in precision agriculture, paving the way for autonomous harvesting and yield prediction. Our work builds on this advancement by integrated improved data augmentation to further enhance detection performance. So So this is the main three step for our proposed approach: data preparation, model design and training, and inference and testing. So we used a dataset focused on orange detection consisting of images from custom orange dataset and subset of fruit 360. The dataset is split into training, validation and testing sets to ensure robust model evaluation. Each image is resized to 2 to 4 cross 2 to 4 pixel for consistency. The dataset contained both oranges and other fruits to improve the model's ability to distinguish between them. In model design and training, for object detection, we selected YOLO V10 due to its high accuracy and efficiency in real-time application. The model was trained using ADAM optimizer with a batch size of 32 to balance performance and computational efficiency. In inference and testing, for real-world deployment, we used OpenCV for frame-by-frame video processing, enabling a real-time direction. The bounding box detection is based on the confidence threshold of 0.5, meaning the model only considered detection with at least 50% of confidence to reduce false positive. So to evaluate our models, the performance we use three key metrics: accuracy, precision, and recall. So accuracy represents the overall correctness of our model, meaning 95% of all classified images were correctly identifies either oranges or non-oranges. Precision 92% indicates that orange were actually correct. A higher precision means fewer false positive. Then recall measures how well our model detects all actual orange images with 90% of the oranges in the dataset correctly identified. Higher the recall ensures fewer false negatives. So here you can see the graph training and validation performance. So this graph shows the training and validation accuracy over 10 epochs. As we can see, training accuracy steadily increased, reaching 99.8% by the 10th epoch. The validation accuracy peaked at 95%, stabilizing after 8th epoch. This indicates that our model successfully learned the features without significant overfitting and ensuring strong generalization. In processed image, we can see the cluster of oranges. It demonstrates the effectiveness of our model in real-world scenario. Here is a bunch of oranges on a tree has been accurately detected with the detected oranges highlighted in cyan color. This visualization confirms that our model can successfully localize and differentiate oranges from the background, making it highly suitable for automated harvesting applications. So to conclude, our proposed YOLO-based model demonstrated high accuracy and strong performance in orange detection, making it suitable for real-time agriculture automation. Results indicate that our model is both accurate and reliable, effectively detecting oranges while minimizing the fault prediction. The balance between precision and recall ensures strong detection performance for real-world application. The added bounding box detection using OpenCV enhances the usability of system for real-time applications. By leveraging data augmentation and transfer learning, we enhance the model's robustness, improving detection in diverse conditions. This system can be integrated into applications like fruit sorting or real-time fruit detection in market. In future, we aim to enhance our model for detecting diverse fruit type and improving performance under occlusion and overlapping fruits. We will explore faster RCNN for higher accuracy and deploy the model on edge devices for real-time, low latency processing. Additionally, integrating our system with autonomous fruit picking robots will further advance agriculture automation. So these are the references which I used. Thank you.
Thank you so much, ma'am. Now we come to the closing of the session. Thank you. I'll just a second. Okay. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this ninth version and all the other previous 8 versions of this conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certifications through email within 2 working days. Further, all the papers have already been forwarded to the Spring Up. The publication will be live within 6 months. So kindly cooperate with our team of SmartCom 2025. Thank you for your valuable presence. Now I would like you all to kindly switch your cameras on for a quick snapshot of this virtual conference. All the presenters, I request you all to kindly switch on your cameras for a quick snapshot. Thank you so much. We'll see you in the next session in 2026. Thank you so much for your presentations. I request you all to kindly log out. We are ending the session. Thank you.